So today we're going to practice how to find the area of shaded regions within circles and then dive into a bit more challenging diagrams to find shaded regions. But if we're looking at this circle, we want to find the area of that shaded region. And we see that that angle in the center is 45 degrees. So this angle is 45 degrees. And if we think about how many degrees are in a full circle going all the way around, the total degrees in circle is 360 degrees. So if the shaded region is only taking up 45 degrees, 45 degrees of the 360 degrees, and when we reduce that, that represents an eighth of the circle. And an eighth of the circle's area. So the shaded region, right, shaded over the total, that can give us the fraction of the circle that is shaded. So if we find the area of the whole circle, we know pi r squared is the formula. So pi and then r is 4 root 3 squared. So we end up with 16 times 3, which is 48 pi units squared. And that's the whole circle. But this 45 degrees, that shaded region, represents an eighth of that whole circle. So 48 pi, that total area, divided by 8 gets us 6 pi units squared. And that's the area of the shaded region. So we're trying to find out what percentage or what fraction of the circle is fully shaded. Okay, so if we're looking at this diagram, we have a 90-degree angle there. So remember, 360 in total, but if we have 90 degrees there, if I reduce, that represents a fourth of the circle. So our area is pi r squared. So 16 squared times pi, which is 256 pi. But we have to divide that by 4. So we end up with 256 divided by 4. (64 pi units squared). It's the area of that shaded region. And so all of these answers we're going to leave in terms of pi. It's just easier to do that. So sometimes you may need your calculator to simplify, and it's okay to use your calculator to help you do some of this scratch work on the side. Okay, so now this is an obtuse angle here. So out of 135 degrees out of the whole 360. So if you can use your calculator to help you, but I did 135 divided by 5, that gives us 27, and then 360 divided by 5 gives us 72, and I can divide each of these by 9, so I have 3/8 of the circle is shaded. So the area of this whole circle, if the radius is 8, we have 64 pi, but then we're multiplying it by 3/8. And it may be easier to do this and reduce. So when you multiply, you're left with 24 pi units squared is the area of that shaded region. Okay, so we have 2 more examples. This one's a bit more tricky, but we want to find the area of the shaded region if the radius of each circle is 6 centimeters. And we want to find first the area of each circle, and then figure out what type of triangle ABC is, and then use these questions to help us determine the area of the shaded region. And that shaded region is that blue space in the middle. So let's start here. If we know that the radius is 6, right? We have 6 and 6, 6 and 6, 6 and 6. Then each circle has an area of 36 pi. Okay, so if each area, and then when I labeled 6, 6, 6, and 6 for all parts, this triangle ABC each has a side length of 12. So it's an equilateral triangle, and that also means it's equiangular. So each measure of these angles is 60. So if we're trying to find the area of this triangle, what we have to do is, well, we can find the area of the triangle, and then in order to get this blue region, we're going to have to subtract. We're going to have to subtract the area of that sector, of this sector, and of this sector. So those pieces of the pie are called sectors. So that's what we're going to be trying to subtract away. But first, let's find the area of this triangle. So we have a base, but we need a height. So I have the height is 6 root 3. So the area of the triangle is base times 6 root 3 over 2. So we end up with 36 root 3 units squared. That's the area of the triangle. Okay. And if we know that this is a 60, 60, 60 triangle, then all these angles are 60, 60, 60. So going back to those previous two examples, how can we find the area of this green, one of the green sectors? So we have a 60-degree angle out of 360 degrees total. So that represents 1/6 of the whole circle. So if the circle has an area of 36 pi, right, this whole circle has an area of 36 pi, then 1/6 of that represents 6 pi. So each of these green areas is 6 pi. So in total, we have 18 pi. And that's representative of all those green areas. So if we have the area of a triangle is 36 root 3, we can take away 18 pi to then get the area of that blue shaded region. And this answer looks super messy. Okay, the answer looks messy, but it's okay. Leave it like that. We can't combine anything. We would need a calculator in order to write it as a decimal. So just leave it like so. Okay. So come up with a plan for each of these problems. Figure out, all right, what do you have to find the big area of, and then what can you subtract away? All right, this one's a bit different. We want to find the area of the shaded region. And the radius of the circle is 5 meters. So what's the area of the circle? I got 25 pi. So if we find the area of the circle, 25 pi, we could subtract away the area of this hexagon to then be left with the area of that blue shaded region. So the area of a hexagon is different. We have to think about how we can find this. We don't know how to find the area of a hexagon, but we do notice that this piece is 5 meters, and that's the radius. And this piece is 5 meters, and that's the radius. And that creates what type of shape? We have a triangle, an isosceles triangle. So if we drew all of these pieces out to the corners, we have 1, 2, 3, 4, 5. So we have 6 triangles. So we have 6 triangles, and we have 1, 2, 3, 4, 5, 6 angles in here. So 360 degrees divided by 6. That means each of those angles at the top are 60 degrees. So let's label that. Okay. This is 60 degrees, and then these are congruent. That means that this is a 60, 60, 60 triangle. So let me redraw a triangle. We know that the side length is 5 and 5, and these are all 60. So when we drop this altitude, I know this is 5 halves, and that the height ends up being 5 halves times the square root of 3. So if we find the area of one of these triangles, then we could find the area of the entire hexagon, because we know that there is 6 identical triangles in there. So the area is 1/2 base times height, or base times height over 2. So we have the full base is 5 times the height, 5 over 2 root 3. And then I'm just going to multiply by 1/2. So we have 25 root 3 over 4 is one of those triangles. So now if we multiply that by 6, we end up with 75 root 3 all over 2. And that's the area of the shaded region. So you're going to have to come up with a plan for some of these problems and make sure that you're going through carefully and marking down what it is that you know, what you can find, and work with your problem solving.